Alright, so as the slide shows, I'm in the process of changing my name. It's now Andrew McMidland, but you'll probably see me as McCluskey elsewhere. And yeah, as Ken introduced me, I work at Data61 in the Queensland Functional Programming Lab. We'll start at the beginning. So earlier this year, I gave a talk on state machine testing using a Haskell library called hedgehog, and it kind of went into the details of how that library worked. One of the questions I got from a few people after giving that talk was, can I use this technique and this technology to test applications that aren't written in Haskell? So the app I was testing in that talk was written in Haskell. And I knew the answer was yes, but I thought it's more compelling to actually do these things. And it also got me thinking about the idea of testing like legacy projects and things that don't really have anything to do with functional programming, which led me to WordPress. So I've kind of got three goals here. The first is to give you all a brief introduction to state machine testing so that you are aware of this powerful technique. Show off that we can use it to test things that aren't written in Haskell or don't use functional programming. And also just to show off some of the techniques from the Haskell world that allowed me to carry out this testing. So with that in mind, I'll start with a very brief introduction about WordPress. We'll move on to property-based testing, state machine testing, and then start looking at some of the techniques. So I used NIXOS, dependent map, servant, and then we'll quickly put it all together and see what that looks like in hedgehog. So a lot to get through. I will go as quickly as I can. WordPress. WordPress got some marketing on their website. It says 31% of the web uses it, and over 60 million people, apparently. Some kind of things that may be more relevant to me in this talk is that it's started in 2003 as a fork of another project that was started in 2001. So if you take that all into account, it's almost legal drinking age, I think. So I think that qualifies as legacy in the software world. It doesn't use functional programming, so it was written and still is in PHP and MySQL. And it has a REST API, uses JSON for the transport stuff, and in my experience, at least, working with it from Haskell and trying to put types around this stuff was underspecified. So, property-based testing. As I mentioned, I'm using the Haskell library hedgehog. For an introduction to hedgehog, the library, Jacob Stanley, who wrote hedgehog, gave a really great talk last year when the library was released. It's where I stole the name from my talk, so I highly encourage you to go check that out for background on hedgehog. You might have heard of QuickCheck or be more familiar with that. It's been mentioned today already. That's another great property-based testing library in the Haskell world. If you're familiar with that, then kind of what we're covering in hedgehog today probably won't be a big shock. So the idea behind property-based testing is that we're applying functions to randomly generated inputs and ensuring that some desirable properties of our code and our functions hold. So with most of these things, examples usually help make that point clearer. So here's the kind of canonical example of reversing a list. We're checking that reversing the list twice yields the same, or the output is the same as the original list. So we start by generating our random list. Here we're generating a list of characters, and the list is between 0 and 100 characters long. And then we specify our property, which is that if we reverse the list twice, the output from that matches the original list. Another important element to property-based testing is this idea of shrinking. So if I have a failure, let's say that our hedgehog randomly generated this list for me, and I checked my reverse property and I had a failure, it might not be immediately clear why I was getting this failure. Is it something to do with the capitalization in my inputs, or what's going on? So property-based testing libraries will then, and hedgehog definitely does this, will shrink your inputs and try them on smaller and smaller values, hoping to give you a kind of minimal input that will still reproduce this failure and make your life easier. So in this case, we might get our input shrunk to the list A, B, and it's clear that there's something pretty fundamentally wrong with our reverse function at this point. So now that we've looked at property-based testing, we can build up the state machine testing, and we'll get there via state machines. So here's a state machine diagram for a turnstile, which is the example I have on Wikipedia and is about the simplest you'll find. As one of my younger colleagues makes me painfully aware, I'm getting pretty old, so not everybody here might know what a turnstile is. This is a turnstile for all of you young'uns in the crowd. You put your money in, and then the little metal arm will spin, and you can then enter the train station or wherever it was you were entering in 1955. So, that's our state machine diagram. Our state machines have states, so in this case our turnstile can be locked or it can be unlocked. It has an initial state, so before we've done anything, our turnstile will be locked. And it has inputs, so if we put a coin into our locked turnstile, it becomes unlocked. If we push the unlocked one, it becomes locked again, so on. So now that we've looked at state machines, property-based testing, we get up to state machine testing. And so the kind of high-level view here is that we model our application as a state machine. We generate our inputs, a la property-based testing, and those inputs are generally transitions between our states. We execute those inputs against our real application. We update our model so that we can update our expectations of what the application state is. And then we check that we haven't broken any invariants. So this is usually checking that our view of the state matches what the application says. So again, an example will hopefully make this clearer. So in this example, we're going to pretend that we've generated or randomly generated the inputs coin, push, and push for our turnstile. We initialize our model state on the left, and we initialize our enterprise turnstile solution on the right. They both come out locked at the beginning, so far so good, everything lines up. We process our first input, in this case the coin, and we can see both our model and the application have gone through a state change and they're now unlocked as we'd expect. And so on and so forth. We push, it does what we expect. Testing wouldn't be very interesting if we didn't encounter failures. So, like failures happen. In this case, we found an error that if we push twice on the second push, it unlocks the turnstile when it shouldn't. And we also see that when we're randomly generating these inputs, we won't often get such simple list of inputs such as the coin, push, push. We'll probably end up with a far more complicated list of 100 inputs to maximize our chances of finding more interesting failures. But luckily, we've got shrinking. And so, like with state machine testing, like with property-based testing, our list of inputs will get shrunk down for us, and we'll get this nice minimal test case. So that all sounds very nice, but it also works in practice, and it works with WordPress. So here's some output from a bug that I found in WordPress using this state machine testing technique. And what's happening here is we're first creating a post, and we're giving it a slug of A, which is the kind of human readable part of the URI. We then send that post to the trash, and then we update the post to bring it back from the trash, and at the same time we're changing the human component of the URI to the letter B. So we decided to make a change. And then when we get that post back from WordPress, something's gone wrong. If we look further down our output, we'll see here that we've asserted that our state, our view of the world, should match what we get back from WordPress. And as we can see, it doesn't. We get this nice diff that says that you expected the slug to be B, and it was actually A. Cool, so that's state machine testing. We'll go back to that a little bit at the end, but we're going to build up first by looking at some techniques that got us there. So the first thing we need to do, if we're going to test WordPress, we need to run it somewhere so that we can actually talk to it. And to do that, we used a tool called NIXOS. So again, we're going to have to build up. We'll start with Nix. For anyone who's not familiar with it already, it's a purely functional language for package management. So we have it gives us referentially transparent expressions to specify our packages in our software. On top of Nix, there's NIXOS, which is the purely functional Linux distribution that takes this concept and then applies it not only to your package management, but also to your operating system and its configuration. And from there, we get to NixOps, which is a tool for deploying NIXOS machines, again using referentially transparent expressions that describe the environment we'd like to deploy and how we'd like to deploy it. So we'll have a look at our WordPress specification. So to get a WordPress environment, first thing we do is specify the package we'd like to install. And so here we're fetching that from GitHub using some functionality from Nix. We then want to install a plugin because we use basic auth, which makes our lives a bit easier when we're testing. We give it a name, we tell it where to get it, and we tell it how to install it, which is in this case unzipping the package and copying the contents to an output directory. Installing a theme is exactly the same. Getting a database can be done in these kind of 5 lines. Nix already knows about MySQL, so we can essentially just say, yes, please. For the web server, it's similarly made easy by Nix and its kind of huge ecosystem of packages. So we'd say we'd like our web server, we give it a host name, we tell it that we'd like the WordPress subservice, which Nix knows about, and when we specify the package we'd like to use to install it, and the plugin and theme that we already specified. The final thing we need to do for this machine is open up some network ports so that we can speak to our virtual environment. So now that we've specified the environment we'd like to run WordPress, we can specify the machine to run it on. So here we're declaring our machine WordPress. We're going to run this on VirtualBox. We're going to up the CPU and memory so our tests don't take so long. And then we're going to run it headless because we don't need to see any GUI for it. And that's it. So we have our referentially transparent expressions declaring what we want to deploy and how we want to deploy it. And this can all go in version control. And then when we want to deploy it, we run NIXOS create. So now we're actually using NIXOS. We create a deployment. We call it WP. We deploy the deployment that we just created. And this will actually go off and create our VirtualBox machines and everything for us. We can then query the deployment and find out what its IP address is and whether it's running. And we can SSH into the machine and poke around and look at logs and things to help us diagnose problems. So now we have WordPress. The next thing I want to talk about is a type called DMAP. So to start with, I want to motivate why I ended up using this, this data structure. So here's an example of the JSON object that you might use to create a post in WordPress. And here's another one. So as you can see, there's a pretty big variation in how we might specify a post. So we can specify all sorts of combinations of fields to create a post. And so when we're dealing with kind of optionality in Haskell, it's pretty natural to think of using maybe. And so that was kind of the first thought that came to my mind. Maybe I can just have a record and make everything optional, right? It's simple. The problem here is that this doesn't really match how WordPress works very well, and it ends up getting a bit cumbersome because you have, in many cases, you might be specifying a post with 2 or 3 fields, but you've got all of these nothing values everywhere, and that makes life a bit awkward. Another solution to this problem that I've seen before is having a type for each use. So if we were writing an application and had a very targeted use for WordPress's API, we might have a type for each one of those kind of handful of uses, and that would encapsulate what's required for each use case, and that would be kind of the end of the story. Here, though, we're testing WordPress. We want to exercise as much of the API and those combinations of field values as we can, and so again, this doesn't really apply. And that brought me to DMAP. So some colleagues of mine were using this also to work with JSON. And yeah, I found out about it, gave it a go, and it seemed to be, or turned out to be a good fit. So a DMAP is a heterogeneous map where the type of each value in the map depends on its key. So you get type safety and heterogeneity. So if we start, we've got our regular Haskell map. It has a key value, a key type for the key and a type for the value. So all the values have the same type. For DMAP, it's parameterized on a type constructor for the key and another type constructor that wraps each of the values in our map. So that might get a bit clearer when we look at our key type. So here's a key type, or part of the key type for a post. And we'll see our post key type here takes this A parameter. And that is capturing the type of each value depending on the key. So the dependent nature of the dependent map. So as an example, if we look at the post title key, it has type post key of text, which means that whenever we have a post title in our DMAP, the value that corresponds to that key must have type text. To create one of these, we have a from list syntax, and again we're using identity here just to wrap each of our values because we need a type constructor there. If our type constructor around the values is an applicative instance, we get a slightly nicer syntax using this operator. And the other, so we have our type-safe heterogeneous collection. The last thing I wanted to talk about is the ordering. So usually if you're using data.map or any sort of map structure, you want an ordering on your keys, which gives you the better performance for lookups and insertions and things like that. And in the Haskell world, that usually means defining an instance of ord. If we do that for post key, you'll see here if we substitute in the type, we end up with a compare operation that's comparing two post keys that have the same value type, meaning we can only ever compare two keys whose corresponding value type is the same, which means we've kind of lost our heterogeneous map, and it's not going to help us. So DMAP comes with another class to do your key ordering, and if you do decide to check it out, you'll need instances for this. And thankfully there's some template Haskell, which I wasn't aware of at first, but again my colleague pointed me to, which will take away that kind of boilerplate for you. Alright, so the next piece in the puzzle was using servant. So I used this to specify WordPress's API and generate some client functions that I could use to actually run some web requests. So yeah, servant kind of gives us this. This isn't a real type, but it kind of gives you the idea that you specify your web API as a type, and you get back your client functions. So here's part of WordPress's API for posts, and here it is specified as servant. So I'm not going to go into the details of how servant works. It's got good documentation. It's reasonably well known. But yeah, we kind of have this reasonable correspondence from our API endpoints to what we have in servant. The cool part there is that once we've specified our type, we can use that type to implement the WordPress API using Haskell if we chose. We can also use servant's client function to get a collection of these client functions. So now we can call getPost, which is a regular Haskell function, and use our regular Haskell data types with that function to then make a web request to WordPress and get back a Haskell value as a result. So we now don't have to worry about the web stuff so much. One interesting part of using servant for this problem was handling query parameters. So here's all of the keys for a list post type. So these are kind of the different ways that we can filter our posts when we're asking WordPress to list them for us. And again, we're using a DMAP because we kind of had a similar problem that we spoke about earlier. From here, if we have a look at the list endpoint in our servant API, we'll see that we have it takes a GET request, which means that there's no, well, at least no standards compliant way to provide all of these filter parameters that isn't using query parameters. So we have a query param map combinator there on the first line, which tells us that we're using a DMAP to specify them. The interesting thing about this is that query param map doesn't come from servant. It's something that I define myself as part of this library. Because servant doesn't know that DMAP exists as far as I know. And so, yeah, servant has this kind of API for specifying web types. It's really powerful, but it also allows us to extend it. And so here we define our query param map combinator. From there, we need to give it an instance of this hasClient class, which is essentially telling servant that when I see this as part of a client API, what do I do with it? To define this, we then need this client type, which is saying if I see query param map as part of a bigger API, how do I turn that into a client function that you can use? And in this case, we add a DMAP parameter to our client function. From here, we get to implementing how we actually process that. So when we're processing one of these client functions, how does this work? And in this case, we can take our DMAP parameter and we fold over the key value pairs, turn them into their query parameter representation, and then use a servant function to put them into the request. So I'm not going to claim this was straightforward. I certainly had to look through some examples and documentation and kind of piece this together, but I guess the message is that A, it was possible. I could extend this to meet my needs. Yeah, so it was possible to do it, and B, it was actually easier than I thought it would be, which was cool. Cool. So now we've kind of looked at some of the big pieces, and now we're going to have a quick look at how we actually put this together into some of the tests. So we start with our model state. Here we have a type synonym for called post, which is just a regular data.map from the Haskell ecosystem, which is mapping post IDs, which are integers here, to state post, which is a new wrapper around a DMAP that's keeping track of things that are state. We're going to ignore the var thing. If you want details on that part of hedgehog, then see my earlier talk. And yeah, we use that in a record here that just at the moment contains posts, but as our tests grow, we're going to be keeping track of more things in state. So we have state, we now need inputs. So I had an example earlier of some output where we found a bug in WordPress, and so we're going to have a look at those inputs. With create post, as you'd expect, we take a post map specifying the details of the post we'd like to create. We have a delete input, which takes the ID of the post we'd like to delete, and then another flag, which is just saying, will we bypass the trash and delete it for good, or will it go to trash? We have an update, which is very similar to the create, except we take the ID of the post that we're now updating rather than creating. And finally, we get, where we specify the ID we'd like to get, and we'll get back a map, a DMAP containing the post. So we have our state, we have some inputs, and now we're going to put it together and start specifying some properties. So to start with, as our property-based testing, we generate some random inputs. And here I'm using a helper function I've defined to generate our post input. We then need to tell Hedgehog how do we execute one of these inputs, what do we do, like how do we interact with WordPress when we see one of these. We start by with some debug output using this annotate show function. So if we do get errors, we have some kind of helpful output to diagnose the problem. We then actually, this is where we specify the servant action. So we're using our create post function that we got from servant and passing in some auth and the post data that we'd like to use. And then here we're pulling the post ID out of the response. So we get a full DMAP with all of the post information, and here we're just pulling the ID out so we can use it as the key in our state. And then we run the servant action and use this eval either function from Hedgehog, which means that if this web request errors out, that error report will be associated with this line, so we get slightly nicer debug output. And then finally, once we've created our post and we get a response back and nothing's gone wrong, we can put it into our state. So here I'm using lens. Lens also turned out to be very useful for manipulating state here, but I didn't have time to talk about it, so come find me tomorrow if you want to know why. Cool, so we can create a post. To update posts, we do something very, very similar. The interesting part here is the require. So we're actually specifying a precondition now. So we saw before that when we're doing property-based testing and state machine testing, we have this notion of shrinking when we see failures. And so while we're shrinking our inputs, we might remove an input that was used to create a post that we're now trying to update. And so this require precondition will ensure that the post we're trying to update is still in our state, and if it's not, then we abort running this particular check. Getting posts, again, a very similar story to the ones we've seen. The interesting part here is that now we're actually specifying our post condition, our property. So once we've gotten a post back from WordPress, we can look it up in our state using the ID and just make sure that all of the fields match, and it's as we expect. And that's it. That's it altogether. So in conclusion, we had a look at state machine testing. Hopefully I've shown that it's a powerful technique for testing stateful systems, and that your app doesn't have to be written in Haskell or involve functional programming at all. We had a look at NIXOS, how it allowed us to use referentially transparent specifications for our deployment, and that we could deploy those in just a few commands. We had a look at DMAP and how its heterogeneous mapping from keys to values preserved type safety and allowed us to more naturally fit WordPress's JSON API. Yeah, we covered that. And then we looked at servant. So we could declare our API as a type, get our client functions almost for free, and then we could also extend servant's API language as needed. And so the final thing I want to say is, with all of this, hopefully I've kind of inspired you and shown you what's possible, shown you some interesting techniques for testing, and go forth and test. So if you're not writing or getting to use functional programming in your day-to-day job and would like to try out Haskell and these things, then go and give it a go. You can definitely do it, and we're here to help. Thanks.
Any questions?
Hi. What kind of bugs did you find in WordPress doing this testing?
So the focus of this work for me was really how do I deal with WordPress's API. So I kind of took a chunk of the API, and I haven't actually implemented a huge amount of it yet. But what I have found, I found that bug that I listed before. I found another bug which was to do with concurrency, which I also reported to WordPress, at which point they informed me that they don't actually have any sort of thread safety, or it's just not on their radar. So that kind of wasn't a bug as far as they were concerned. The other bug that I showed you was also not a bug as far as they were concerned. It was like a corner case, and it was apparently a weird thing to do, so not a bug. Yeah. I mean, I guess kind of what I was talking about using DMAP was kind of good, because as I was working through the testing, I was kind of discovering the API. So those were kind of the two things I would consider bugs that I found. But there were a lot of quirks in the API around how it would just default values and randomly append numbers to the end of values that had conflicts with what was in existing state. So if it wanted uniqueness and it found a conflict, it would just randomly append numbers to so there were a lot of quirks that I discovered this way, but I couldn't really call them bugs, because I guess WordPress doesn't really have a strict definition of how things should work.
Yeah. Thank you.
Oh yeah, sorry about that.